नमस्कार मित्रांनो, माय बेस्ट गुरु चॅनलमध्ये आपले मनापासून स्वागत. आम्हाला प्रोत्साहन देण्यासाठी सबस्क्राईब बटनवर क्लिक करून सबस्क्राईब करून आम्हाला मदत करा. म्हणजे आम्ही तुमच्यासाठी घेऊन येऊ जास्तीत जास्त व्हिडिओज. तसेच आमच्या नवीन व्हिडिओचे नोटिफिकेशन मिळण्यासाठी घंटीच्या चित्रावर क्लिक करा. Dear students, lesson number 2, work and energy. Important topics in this lesson: work, energy, mechanical energy, law of conservation of energy, and free fall. Dear students, now question number 1, write detailed answers. A. Explain the difference between potential energy and kinetic energy. Potential energy, kinetic energy. 1. The energy stored in an object because of its specific state or position is called its potential energy. The energy which an object has because of its motion is called its kinetic energy. 2. A compressed spring is an example of potential energy. A moving car on a road is an example of kinetic energy. 3. Formula to get potential energy is equal to mgh. Formula to get kinetic energy is equal to half mv square. B. Derive the formula for the kinetic energy of an object of mass m moving with velocity v. Suppose a stationary object of mass m moves because of an applied force. Let u be its initial velocity. Here u is equal to 0. Let the applied force be F. This generates an acceleration a in the object, and after time t, the velocity of the object becomes equal to v. The displacement during this time is s. The work done on the object W is equal to Fs. W is equal to F multiplied by S. According to Newton's second law of motion, F is equal to ma. Equation 1. Similarly, using Newton's second equation of motion, S is equal to ut plus half at square. However, as initial velocity is 0, u is equal to 0. S is equal to 0 plus half at square. Therefore, S is equal to half at square. Equation number 2. Therefore, W is equal to ma multiplied by half at square. Using equation 1 and 2. Therefore, W is equal to half m at square. Using Newton's first equation of motion, v is equal to u plus at. Therefore, v is equal to 0 plus at. Therefore, v is equal to at. Therefore, v square is equal to at square. Therefore, W is equal to half mv square. Using equation 3 and 4, the kinetic energy gained by an object is the amount of work done on the object. Therefore, Ke, kinetic energy, is equal to W. Therefore, Ke is equal to half mv square. Prove that the kinetic energy of a freely falling object on reaching the ground is nothing but the transformation of its initial potential energy. When the object is stationary at A, its initial velocity is u is equal to 0 and the object is at the height of h. Therefore, Ke is equal to mass multiplied by velocity square is equals to mu is equal to m multiplied by 0 is equal to 0. Therefore, Ke is equal to 0 meter per second square at the beginning, equation number 1. Let us see the potential energy of the object when it falls on the ground. When it falls on the ground, its height is equal to 0 meter. Therefore, Pe is equal to mgh is equal to m multiplied by g multiplied by 0 is equal to 0 meter per second square. Therefore, Pe, potential energy, is equal to 0 meter per second square when the object falls on the ground, equation number 2. Therefore, kinetic energy is equal to potential energy from equation 1 and 2. Energy decreased and became 0 when the object came on the ground. It shows that it is nothing but the transformation of potential energy into kinetic energy. Determine the amount of work done when an object is displayed at an angle of 300 with respect to the direction of the applied force. Answer. The formula to obtain work is W is equal to Fs cos theta. Here theta is equal to 300. W is equal to Fs cos theta. Therefore, W is equal to Fs cos 300. Cos 300 is equal to root 3 upon 2. Therefore, W is equal to Fs root 3 upon 2. E. If an object has zero momentum, does it have kinetic energy? Explain your answer. Answer. Momentum is equal to mv. Momentum here is 0. Therefore, momentum is equal to m multiplied by v. Therefore, 0 is equal to m multiplied by v. Therefore, 0 multiplied by m is equal to v, means v is equal to 0 meter per second. Kinetic energy is equal to half mv square. Therefore, Ke is equal to half m multiplied by 0 square. Therefore, Ke means kinetic energy is equal to 0. Therefore, if momentum is 0, then its kinetic energy is also 0. F. Why is the work done on an object moving with uniform circular motion 0? Answer. When the applied force does not cause any displacement or when the force and the displacement are perpendicular to each other, theta is equal to 90 degree, the work done by the force is 0 In uniform circular motion, the force and the displacement are perpendicular to each other. Therefore, the work done on an object moving with uniform circular motion is zero. Question number 2. Choose one or more correct alternatives. A. For work to be performed, energy must be dash dash. Answer. Transferred from one place to another and transformed from one type to another. B. Joule is the unit of dash dash. Answer. Work and energy. C. Which of the forces involved in dragging a heavy object on a smooth horizontal surface have the same magnitude? Answer. Gravitational force of friction. D. Power is a measure of the dash dash. Answer. The rapidity with which work is done and the slowness with which work is performed. E. While dragging or lifting an object, negative work is done by dash dash. Gravitational force and frictional force. Question number 3. Rewrite the following sentences using proper alternative. A. The potential energy of your body is least when you are dash dash. Sleeping on the ground. The potential energy of your body is least when you are sleeping on the ground. B. The total energy of an object falling freely towards the ground dash dash remains unchanged. The total energy of an object falling freely towards the ground remains unchanged. C. If we increase the velocity of a car moving on a flat surface to 4 times its original speed, its potential energy dash dash will not change. If we increase the velocity of a car moving on a flat surface to 4 times its original speed, its potential energy will not change. The work done on an object does not depend on dash dash. Initial velocity of the object. Question number 4. Study the following activity and answer the questions. 1. Take 2 aluminum channels of different lengths. 2. Place the lower ends of the channels on the floor and hold their upper ends at the same height. 3. Now take 2 balls of the same size and weight and release them from the top, and the channels they will roll down and cover the same distance. Questions. 1. At the moment of releasing the balls, which energy do the balls have? Answer. At the moment of releasing the balls, they have potential energy. 2. As the balls roll down, which energy is converted into which other form of energy? Answer. As the balls roll down, potential energy is converted into kinetic energy. 3. Why do the balls cover the same distance on rolling down? Both the balls have same potential energy, therefore both will cover the same distance. 4. What is the form of the eventual total energy of the balls? Answer. Kinetic energy. 5. Which law related to energy does the above activity demonstrate? Explain. Answer. Law of conservation of energy is related to the above activity. In the above example, potential energy is converted into kinetic energy. Energy remains same in both the cases. Question number 5. Solve the following examples. A. An electric pump has 2 kilowatt power. How much water will the pump lift every minute to a height of 10 meter? Power P is equal to 2 kilowatt is equal to 2 multiplied by 10 raised to minus 3 watt. Time T is equal to 1 minute is equal to 60 seconds. Height h is equal to 10 meter. Formula for it is P is equal to W upon T is equal to mgh upon T. Therefore 2 multiplied by 10 raised to minus 3 is equal to m multiplied by 9.8 multiplied by 10 upon 60. Therefore m is equal to 2 multiplied by 10 raised to minus 3 multiplied by 60 upon 9.8 multiplied by 10. Therefore m is equal to 1224.5 kg. Therefore the pump will lift 1224.5 kg water per minute. B. If a 1200 watt electric iron is used daily for 30 minutes, how much total electricity is consumed in the month of April? P is equal to 1200 kilowatt multiplied by 10 raised to minus 3 kilowatt. Time T is equal to 30 minutes is equal to 0.5 hour. Number of days is equal to 30 days because there are 30 days in April. So the formula is E is equal to P multiplied by T multiplied by number of days. Therefore E is equal to 1200 multiplied by 10 raised to minus 3 multiplied by 0.5 multiplied by 30. Therefore E is equal to 1200 units. Therefore total electricity is consumed in the month of April is 1200 unit. C. If the energy of a ball falling from a height of 10 meters is reduced by 40%, how high will it rebound? Height h is equal to 10 meter. Therefore PE1 means potential energy 1 is equal to 100% at the beginning. Therefore PE2 is equal to PE1 minus 40% of PE. Therefore PE2 is equal to 60%. Therefore, PE1 is equal to E1 minus E1 means energy 1 minus 60% means 60 upon 100 of E1. Therefore, PE2 upon PE1 is equal to mgh2 upon mgh1. Therefore, PE2 upon PE1 is equal to h2 upon 10. Therefore, 60 upon 100 is equal to h2 upon 10. Therefore, 60 upon 100 multiplied by 10 is equal to h2. Therefore, h2 is equal to 6 meter. Therefore, it will rebound 6 meter high. D. The velocity of a car increase from 54 km per hour to 72 km per hour. How much is the work done if the mass of the car is 1500 kg? Answer. Initial velocity of car u is equal to 54 km per hour is equal to 54 multiplied by 1000 per 3600 meter per second is equal to 15 meter. Final velocity v is equal to 72 km per hour is equal to 72 multiplied by 1000 upon 3600 meter per second is equal to 20 meter per second. Mass m is equal to 1500 kg. Then W is equal to what? W is equal to final kinetic energy minus initial kinetic energy is equal to half mv square minus half mu square is equal to half m v square minus u square is equal to half multiplied by 1500 multiplied by 20 square minus 15 square is equal to half multiplied by 1500 multiplied by 400 minus 225 is equal to half multiplied by 1500 multiplied by 175. Therefore, W is equal to 750 multiplied by 175. Therefore, W is equal to 1,31,250 joule. Therefore, the work is done 1,31,250 joule. Ravi applied a force of 10 Newton and moved a book 30 cm in the direction of the force. How much was the work done by Ravi? P is equal to 10 Newton. S is equal to 30 cm is equal to 0.3 meter. Therefore, W is equal to F multiplied by S. Therefore, W is equal to 10 multiplied by 0.3. Therefore, W is equal to 3 joule. Therefore, 3 joule work was done by Ravi. आम्हाला प्रोत्साहन देण्यासाठी सबस्क्राइब बटनवर क्लिक करून सबस्क्राइब करून आम्हाला मदत करा, म्हणजे आम्ही तुमच्यासाठी घेऊन येऊ जास्तीत जास्त व्हिडिओज. तसेच आमच्या नवीन व्हिडिओचे नोटिफिकेशन मिळण्यासाठी घंटीच्या चित्रावर क्लिक करा.